In this tutorial I would like to show how to create a HTML5 web HMI which connects to an SQL database. This is realized by using SpiderControl components. We have a SpiderControl SCADA server which connects through a database driver to XAMPP installation, which consists of an Apache web server and an SQL database. The idea is that the driver, the database driver in the SCADA web server, uses a PHP script located in XAMPP to read and write variables from the database, and this PHP script can be adapted to all kind of needs. So this is a quite powerful, easy and flexible solution to establish such a connection, to establish a system. To set up this example, you can download a zip file containing various components. The first thing is this PDF file, which explains in detail how to install the database. We have the PHP script, which must be copied to the XAMPP installation, and we have the sample database itself, and here we have the HMI project, the SpiderControl project, designing the HMI. So these are the variables that can be found in our simple sample database, and this is the web HMI that we have designed using SpiderControl. So this web HMI now directly connects to the variables in the database, and if we press update, we will see that the value that we just wrote from our SpiderControl HMI has changed in this database. The components that we need to set up these things is the SCADA editor, which can be found on SpiderControl in the download area. So select the SCADA editor to design the HMI web server, and select one of these SCADA web servers which can be installed on your PC and which will do this sample installation. So this is both of these components after installation, the SCADA web server and the HTML5 editor. Here we come to the description of how to set up the database, the XAMPP installation. First thing is where you can download it from, so you can get this installation from there. You should then start the Apache web server and the MySQL task. Concerning the Apache web server, it is important that you connect it to a different port number than 80, as port 80 is already reserved by the SpiderControl web server. So here this is explained how to do, and then we have to create this simple database in the SQL server to establish the connection from SpiderControl to these variables. You can import this table using the sample PPOs, process points, and after we have done that, we can continue by designing our web pages. So here we see again the administrator tool of this XAMPP showing the variables that we will use in our project. The PHP script, which is part of the zip file you can download, should be copied to the XAMPP installation directory. So it is inside this htdocs directory, inside this subfolder. So this is the PHP file which is responsible to read or write variables from SpiderControl SCADA to the database. If we look at the PHP script, we can use it as is in this sample, but we can also modify it. First thing we have to look at is to which database and which table it should connect. This is defined here. Then basically we have two methods for writing or reading variables from the database, and they're just implemented in a quite simple way, and they will return the value names and the value contents from the database through a simple XML description, which is then read out by the SCADA server. We will now modify our SpiderControl HTML5. First, we have a look at the SCADA configuration. So this is the driver configuration, and we choose here the driver type. If we haven't got a driver yet, we can add one, and we would select the DB type. The default parameters are quite fine for our example, and we will just have a look to the configuration of this sample. So the IP address of the driver source is local, of course, because XAMPP is on the same PC. Then we must enter the different port address of the Apache web server. Here we reference the scripts for read and write. In this case it's the same script for read and write. This simple example will do a periodic update of the variables. It reads out the complete table every second, and thus gives us the updated value. The concept that we have chosen here is quite flexible, so we can also choose for other variants. We can implement scripts which are executed by writing on a trigger. We can select different tables, select specific variables to reduce the load. We will now add another edit field to access another variable. We would like to see the first variable here in the list, this PPO test1 variable. And to access this variable, we have to enter the name for the PPO description. So the name will start with the driver prefix, which is PLC0, followed by the name of this variable in the table. So this is PPO test1. We will now build and download the modified project to the SCADA web server, where the HTML5 pages will be copied to the working directory of the SCADA server, and we can then update our browser to show the modified page. So this is the working directory of the SCADA server. The HTML5 files will be copied. We will reload in our browser, and we get the updated page, and we're now able to write to this variable. So if we look to the database manager and make an update, it will show our modified value. Here we are.